Hi, and welcome back to another NeoForge modding tutorial. Today we're going to make another block with some advanced features, and it's going to be a rotatable fan that can push entities in a given direction and can be powered on or off. Now we're going to start off by opening up Blockbench, which is a modeling software used to make models that are compatible with Minecraft. Blockbench is free to download. I'll put a link in the description, and it's a really convenient tool. You'll see once we get in, we create a new Java blocker item, and we have this wonderful editor that's similar to a very basic 3D modeling software. On the right-hand side, we can add new cube elements to our hierarchy, and we can rotate them and move them and change their size. And we can also texture our blocks using this tool, so I've just dragged in a few images on the left-hand side, and you can adjust the UVs to place where the textures position themselves on each cube, each element. So we're going to just drop in some of the default furnace textures, and then we're going to make a custom animated texture to represent the spinning rotor of this fan. It's important to note we're orienting this block to face north by default, because that's how most Minecraft blocks handle their default orientation. Now I've exported that block model we just made as a Java Edition model, and we can see we now have this JSON file. I've placed it inside of our mods assets under models and block, and it's called box fan. You'll notice a few things. One, we have this textures tab, which indicates how each of these textures map to the faces. You'll see the zeros and the ones are referencing these two textures, the furnace side and top. We need to make sure to put these in the right format so Minecraft can recognize them. We do Minecraft :block / furnace side, and we'll put the same thing down here. Also importantly, you can set this when you create your model, but I forgot to. We just need to make sure that the parent is of type Minecraft block / block. Now we're going to go ahead and make the animated texture for the rotors. Now I'm making a texture for our rotors inside of paint.net, so I've gone ahead and blocked out the area of our rotors. That's a 12 by 12 square inside of our file, which is a 16 by 16 texture. The rest of it we can leave blank or we can fill, it doesn't really matter because it will be obscured in our model. We can see I'm adding new layers with the rotor spinning a little bit on each frame. Now that we have each frame drawn, I'm actually going to expand out the image downwards and place each frame stacked on top of each other vertically. Now they're 16 by 16, so I'm moving each frame down 16 pixels from the last one, and then I'm also adding a background here. This is going to allow us to feed this to Minecraft as an animated texture. Now I've saved this as a PNG inside of our mods assets and textures and block folder. If we look at it here, it's 16 by 144 pixels. 144 is 16 times 9. I've also exported the single frame for the idle state of our fan. So when it's off, it's just going to sit on this texture. It's not animated. We want it to be static. Now, the secret sauce for animating textures in Minecraft is that it's supported out of the box to have looping textures. We have a .png.mc meta file of the same name as our long box fan texture, and inside of it we just have some configuration information about the animation. Now there's more settings you can add here, but for our purposes we just care about interpolate and frame time. So the frame time is how many ticks there are for each frame of your animation. In our case, we want it to be fairly fast, so we have 1 tick per frame. 1 real-life second is 20 ticks in-game, so this animation will loop about twice a second. The interpolate setting, when set to true, will make it so your frames smoothly fade into each other. We don't want that to happen, we want them to jump into the next frame immediately. The last thing we need to do to make sure our assets are ready to go is open our box fan model back up and make sure that the texture for the rotors is set to the right variable name. Basically, we're going to create 2 models that either use the static texture or the animated texture for the rotors. And to do this, we need the rotor texture to be some variable that can be set. And what we need to do is replace the missing texture for our rotors with a variable that we will populate in the submodels. So I'm just going to call this fan. Now you can also do this inside of Blockbench by adding a new texture with this name. If you don't want to mess around with the JSON file and figure out which element corresponds to which side, that's a better option. Now we're going to implement our box fan. We're going to start by making a new class to handle the logic for our block. We'll call this box fan block. Now previously we made the toggler block, which has functions for changing the lit state based on whether it's powered by redstone. We want all this logic plus the directional logic, so we're going to extend the toggler block class. And then we'll go to the toggler block class to take the methods that we need to override, which are these two. Paste them in here. We also need to grab the register default state to put in the constructor. First of all, we'll add another property to our block state definition. We'll call .add, and we'll use the facing property from Minecraft's default block state properties. Now this is just an enum with all of the directions in it. We'll set our default state for placement. So we'll take context.getClickedFace.getOpposite. Let's do a little cleanup here. And in the constructor, we'll set the default block state, which is a north-facing block. Now we're not going to implement the functionality of moving entities for now, because I just want to focus on the block model. We'll return to that after we've generated our block model. So now let's register this block with our blocks and items. Create a new holder for our box fan, and we'll register it. And of course, we create a new box fan block. In our case, I'm going to copy the properties from a dispenser just so it has the right sounds and break time. Now don't forget we have to set the ID. And we also want to make it require correct tool for drops. Now we create the respective item. New block item, linking to our box fan block. Create a blank item properties. Make sure we set the ID. And that's it for our item. Now we can head over to our model provider and start generating the model for our block. I'll create a new section here for our box fan. And we're going to do a very similar thing to the toggler block. We'll create a new texture mapping. This is going to be box fan texture idle for the off state. And we will create a new texture mapping. And conveniently, Minecraft already has a texture field called fan. They use it for the coral fans. But if you did want to create a new texture slot with a, say, instead of calling it fan in our model, we called that state rotor. We could make a new texture slot calling texture slot.create with the ID of it. And then we would use this texture slot as the reference inside of our texture mapping. But we're not going to do that. We're just going to use the existing one. So we'll call .put and use the fan texture slot. And we'll specify the location of our texture. We know that's inside of our mod. And we know that it's called block folder box fan idle. Now we can create a model based off of this texture. But importantly, in our previous steps, we used this cube all template. And what we're going to do here is create a new model template that represents the base of our box fan without the rotor texture specified. So as a static field, we'll make a new model template, and I'll call this box fan. Simply create a new model template, and you'll see it takes a few variables. The first one is an optional containing the location of the model. The second one is a suffix, an optional suffix that is appended to the names of any models generated using this model template. We can leave this empty. And the last parameter is any number of texture slots that are required by this model template. In our case, we only require that the fan field is populated. So we'll make an optional resource location. This is our model. We know that it's inside of models, which is the default. That's assumed it's inside of models, inside of the block folder, and it's just called box fan. The next is our suffix, which we don't want, so we'll make that empty. And lastly, we'll put the texture slot for the fan. Now we can reference this model template as an easy way of generating models that are parented to our box fan model. So we'll reference the box fan model template and call .create with a resource location that specifies the name of this model that we're going to save. We'll call it box fan idle. The next argument is going to be the texture mapping. Just going to format this. So we'll input our texture mapping, and the last one is the block model generator output. Now let's repeat this for the active state. And our animated texture is just called boxfan.png inside of the block folder, inside of our textures folder. And again, we use the model template to create a new model. We need to make sure that the models we're creating here have names that don't clash with the base model that we created. You remember the base model is just called boxfan, so I need to make sure I have this active suffix, otherwise we're going to have a duplicate model and that will give us an error. Now we need to link these two models into a new block state definition, just like we did for the toggler. Create a new block state generator, call this boxfan generator. And it's a multivariant generator based off of our block. Now we can directly copy what we did before, which is a Boolean model dispatch for our lit state. Just make sure to switch out your models for the correct ones. We'll take the active model and the idle model. Now we need to add the property dispatch for the rotation of our block. Now this is very easy. We just do width, and there is one built in for us, just called create facing dispatch. And that will automatically create the block states for the rotated version of our block model. Now we register this block state generator to our block. That's the block model handled. Now we need to do the item model, which is exactly as we did above. We'll use the idle model for the item. And now we can generate our data and see what we get. It succeeded, and if we look at the log, we see we generated 4 new files. Let's have a look at our generated assets and see what we got. We have a block state file that defines every permutation. See the idle and the active and different rotations. We have an item definition that links to the idle block model. And inside of our models, we have generated the active one and the idle one. And the only difference between these two is which texture they're using. Now there's still things we want to do before we launch the game, and that is set up the loot table for this block and add it to our creative tab. To do this, we'll open up our block loot table sub-provider, and we'll make it drop itself. While we're at it, let's handle the toggler. Make sure we add it to our list of known blocks. And we also need to add this to the mineable with pickaxe block tag. So let's do that. And if we generate our data again, we'll create the new loot table and tag information. Let's go and have a look. Inside of our data, learning the ropes and loot table, we have box fan and toggler. And we also have added it to the pickaxe tag. Awesome. Now we'll open up the creative tabs class and add it to our creative tabs. And we can launch the game and see what it looks like. Now if we open up our creative tab, we can take the box fan and place it down in the world. You'll notice it's facing into whichever direction we place it, and this isn't the desired behavior. I'd like it to face the opposite way. We can take out the .getOpposite call inside of our getStateForPlacement method in the box fan block. Now if we place it, it faces upwards. Let's power it with a lever and see what this looks like. Our animation is playing just as we hoped it would. We now have a spinning fan. Now back in our box fan class, to make this actually push entities that are in front of it, we're going to override the tick method. I've just pasted that in here. It takes 4 arguments: block state, server level, block position, and a random source. Now inside of here, first we're going to make sure we call our super.tick. This is the method that comes from our toggler block class, and it's important that we preserve that. Otherwise, our block won't be able to be turned on and off by the redstone power. Now here's where we're going to try to add our logic to push entities that are in front of it. You can see I've already created this useful utility function. It's called createAABB, extending in direction, and essentially what that does is create a 3D volume that's in front of our block in whatever direction it's facing. So using the server level, I'm going to grab any entities that are nearby. I'm going to use the getEntitiesOfClass function. And we specify the entity class that we want to pick up. In our case, it's going to be all entities. So I'll take the base entity class. And then we'll pass our volume in. So what we'll do is, first of all, we need to get the direction that this block is facing. And we can do that by calling state.getValue and then specifying the property. So the property is facing. And I'll make our volume. We'll use this helper method we created, pass in the direction, the origin position, as well as the length. We're going to say this is 8. And now we have a list of entities that match this search. So I'm going to iterate through them. Now inside of here, we're going to do something to the entities. And in this case, we're going to call entity.push so we can apply some force to it. I'm going to do a similar trick that I did in the helper method, where we create a vec3, which is a 3-dimensional vector, just basically representing the force we're going to apply. We'll start at 0, so it's an empty vector, and then we will extend it by using the relative function in a specific direction. So I'm going to extend this vector in the direction that we are facing, with a small value because this is going to be applied almost every tick. So we'll feed this into our push function. And that should be enough to push our entities. One more thing here, this should only apply if it's turned on, so we'll use state.getValue to figure out if our block is enabled or not. We'll check if it's lit, and if it is, we do this. There's one more thing we need to do. Tick does not get called automatically on a standard block like this. It needs to be scheduled. So it will be scheduled when we turn off or on our block, but we need to make sure that it repeatedly gets scheduled after that fact. So inside of our tick, we're going to schedule another tick for the future, and that will continue to call itself. To do that, we'll call server level.scheduleTick, put in the block position, the block that we're ticking, so in this case, it's going to be our box fan. and the delay. This is how many ticks in the future we want to schedule this next one. I'm going to put 2 just because it doesn't need to be quite every tick, and I think this will do the job. Have a look at all of this all together, and we can go ahead and launch the game and see what happens. So we're back in our testing world. I'm going to put down a box fan. I'm going to turn it on. We can see it's spinning. I'm going to test it out with this item. There you go. Now this also works for any entity. And if we place it in another direction, let's see if this works. There we go, getting pushed. Should work for items as well. Lovely. Now I'm sure you're going to want to see what happens if I stand on it. Disappointingly, nothing happens. This is because the way that the server handles player movement is a little bit different, and it has to be confirmed on the client too, not just the server. We're going to have to write a little bit of custom networking so we can let the client know that it should be pushed by this fan. In order to allow us to arbitrarily move the player with some impulse force from the server side, we need to create a packet that goes to the client and tells it what force it should apply. To do this, we're going to start off by making a new package, and we're going to call this network. Inside of this, we'll create a new class that represents the packet that gets sent to the client to tell it what force to apply. We'll call it client-bound impulse packet. Now this needs to implement the custom packet payload. And we can also turn this into a record. Implement this default method. And the only thing that this packet is going to contain is a vec3 indicating the impulse force. Let's define the type by making a public static final field, custom packet payload.type, and the type is of our packet. And we'll create a new payload type. And we just give it a resource location describing the name of this packet. Now we can make this method return that type. The other thing we need is a stream codec. Codecs in Minecraft are a way of encoding data so it can be used in other places. A regular codec is usually used for local persistence, so saving something to a file, and a stream codec is typically used for sending information over the network. We'll define a new public static final stream codec type. And the generic parameter will be a byte buffer called bytebuff, and then the data that we want to send, which is our impulse packet. We'll call this stream codec, and use the streamcodec.composite method to create it. Now we're going to pass in stream codecs for each type that we want to encode into this. In our case, we only care about encoding in the vec3 impulse. You'll see that vec3 already has a stream codec available for us to use. Now the next argument is going to be a reference to the specific field in this class that we're using. So we can do client-bound impulse packet, impulse. And the last one is going to be the constructor for this object we're going to create when we decode. So that is just going to be our impulse packet, new. Next, we're going to create a static internal class that handles when this packet is received on the client. I'll call this client packet handler. And inside of it, we'll have one method, and it's going to take 2 arguments. The first is our specific packet. So that's just going to be our impulse packet. And the next is the context. So this is going to be an iPayload context. Inside of here, we need to do the action that happens when the client receives this packet from the server. In our case, it's pretty simple. We're going to get the player from the context, and we're going to add delta movement with our vec3. Now we need to register this packet. Inside of our network package, we'll create a new class. I'm just going to call this network. We'll add an event bus subscriber annotation with our mod ID. And this should be registered on the mod bus. Now we'll subscribe to an event. That event is the register payload handlers event. Inside of here, we need to make a payload registrar. We'll do this by calling event.registrar with a version. Now we can register our packet. In our case, this is a packet that only plays from the server to the client. So we're going to use the play to client method. If you have a bidirectional packet or a packet that goes from the client to the server, you can use any of these methods below. We'll pass in the type of our packet, as well as the stream codec to tell it how to encode it. And then we'll specify the handler. So make a new main thread payload handler and pass in the reference to our handler. Now, last but not least, we need to call this method from the server to trigger it. So we're going to go back to our boxFan block class, and first we'll separate out the impulse into a variable. And if our entity is a player, then we'll send the packet. We can use NeoForge's packet distributor to easily do this. Packet distributor.send to player. We need to make sure this is a server player type. And then we'll create a new packet with our impulse. Now you should be good to go. If we run the game, we can see what this looks like. Now we're back in our test world and we can see if the fans affect the player now. And they do. This is exactly what we wanted to happen. And now we have implemented the player side of the movement and also some basic networking. Now, if you've made it this far, congratulations. You've done some awesome work today. I know it's a bit of a long video, but there's a lot to cover. I'm going to be making more of these, so if you enjoyed this, please leave a like, comment. I'm really happy to answer any questions. I'm going to teach you how to make even more advanced stuff in the future. But for now, I hope you have an excellent day.